Hello, I'm Ray, the Ray in the Ray Code. In this video, I plan to review a creational design pattern known as Abstract Factory. I'll be using Java. Now, I produce other videos in other programming languages like C++, C#, PHP, but for this video, I'll be using Java. Now, in this video, I try to cover the whole aspect of the Abstract Factory design pattern. I have divided this video into 4 different sections. I'll put timestamps in the margin. I start with a list of reasons of why a developer would want to study this design pattern. I show you the UML that the game for gave in the elements of reusable object-oriented software. I provide a code example. I also post that code example at my GitHub site and also at my own website, theraycode.org. I also own theraycode.com. I'm trying to use that for another project. I perform a SWOT analysis as to why a developer would want to study the design pattern. You can find me on Facebook, X, and LinkedIn. Please give this video a like and subscribe. Leave a comment. Also, tell your friends about the Ray Code, because the Ray Code rocks. Maybe you can repost this video on your Facebook, X, or LinkedIn page. If you want me to repost you, tell me about you. Most of all, be good. 5 reasons to study the Abstract Factory pattern for Java developers. Modularity encourages code that's easier to maintain by abstracting object creation for UI themes or database drivers. Scalability enables building complex systems like GUI frameworks where object families must evolve without breaking code. Flexibility supports switching between different product variants, example given different OS widgets with minimal code changes. Consistency helps ensures that Java components from the same family are used together, avoiding incompatibility bugs. Testability facilitates mocking dependencies in unit tests by abstracting object creation behind factory interfaces. UML Abstract Factory declares an interface for operations that create abstract product objects. Concrete Factory implements the operation to create concrete product objects. Abstract Product declares an interface for a type of product object. Concrete Product defines a product object to be created by the corresponding Concrete Factory. Client uses only interfaces declared by Abstract Factory and Abstract Product classes. Collaborations. Normally, a single instance of a Concrete Factory class is created at runtime. This Concrete Factory creates product objects having a particular implementation. To create different product objects, clients should use different Concrete Factory. Abstract Factory defines creation of product objects to its Concrete Factory subclass. Hello, my name is Ray of the Ray Code. In this presentation, I want to give you an example of the Abstract Factory creation pattern. I'll be using Java. The Abstract Factory pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. We start with the creation of an interface. The name of this interface will be Abstract Product A. It will require the user of this interface to have an interact method. We create another interface we call Abstract Product B. It will require the user of this interface to have an interact method of which we can pass an Abstract Product A object. Now, let's create the product objects. We start with a product we call product A1. We extend it with the abstract product A. We can use the autocode generator to make our interact method. We have an override for our interact method. We return the message product A1 interacting. Now let's create another class we call product A2. It too is implemented with the abstract product A. We use the code auto generator to generate the interact requirement. From here, we will return the string product A2 interacting. Next, we create the product B1 class that implements the abstract product B interface. We return a string product B1 interacted with abstract product A, a type of object that was just passed in. Next, we create a product B2 class in which we also implement the abstract product B interface. Thus, we are required to have an interact method that takes an object of abstract product A, of which we evoke the interact method. Now, let's create Abstract Factory interface. This is an interface factory for creating families of products A and B. Let's create a Concrete Factory 1 class, which is an interface for creating families of products A and B, which implements the Abstract Factory. Let's add the overrides for creating products A and B. We replace the first null with return product A1. We replace the second null with a return new product B1. We create a Concrete Factory 2 class, which is also implemented with the Abstract Factory. For the first null, we return a new product A2. And for create product B, we return a new product B2. Now, let's create a client class for our demo. We start with the class structure. We have some private variables for abstract product A and abstract product B. In our client method, we run create product A and create product B. And we create a run method in which we have a product B interact with a product A object. Now, let's go to the main method to do our demo. We have a Concrete Factory 1 code setup and run. We do the same for a Concrete Factory 2 object. Now, let's compile and run. And we get using Concrete Factory 1, product B1 interacts with product A1. And using Concrete Factory 2, product B2 interacts with product A2. My name is Ray, always code with a smile. SWOT analysis of the creational design pattern known as Abstract Factory in Java. S. Strengths. Promotes clean separation between interface and implementation layers. Simplifies the addition of new product families. Reduces code duplication across product variants. W. Weaknesses. Increases complexity with multiple classes and interfaces. Can lead to over-engineering in simple applications. May obscure concrete object behavior from developers. O. Opportunities. Ideal for plugin architecture and enterprise-level system design. Enables cross-platform UI development using consistent abstractions. Supports Java applications needing runtime product switching. T. Threats. Misuse can make debugging object creation change difficult, may hinder performance if used inappropriately in resource-constrained apps, could confuse team members unfamiliar with design patterns. Well, that was my video. Please give this video a like and leave a comment. Follow me on X, Facebook, LinkedIn, wherever you can find the Ray Code. Also, I have a Pinterest account. Go figure. Most of all, I want for you to keep coding.